Hi guys, welcome back to the channel. So today we'll be looking at the today's weekly contest question, which is the last question. The maximum strength of a K disjoint subarrays. So here we are given an array which is of nums and then of length n, and then we are also given one more integer which is k, and then we suppose, let's say, the strength of the K subarrays is given like this. This is the strength of the given array, given subarray, like combination of all the arrays. And then we need to select k disjoint subarrays from the nums such that the strength is maximum. And then we need to return the maximum possible strength that can be obtained. So suppose, let's say, we have particular nums like 1, 2, 3, and then minus 1 and then 2. Now when k equal to 3, we need to pick 3 subarrays which is present in the nums, and then those arrays should be disjoint. That means, let's say I take 1, 2. Then I should take 3, but I cannot take 2, 3 and then 1, 2. I cannot take 1, 2 and then 2, 3. So those should be disjoint. That means there should not be any intersection between two subarrays. So that is a condition it has been mentioned. And then one more thing is, whenever we pick k subarrays, let's say we pick k subarrays, then the strength of those subarrays is going to be sum of 1, which represent the all the elements which are present in that particular subarray, and then x is going to be the number of subarrays which is k, which is k for this particular case. If we take k, then it is going to be k, and then sum of 2, and then this is going to be x minus 1. That means k minus 1. So it is sum of all these elements. Suppose, let's say, if we represent for ith element, then ith element is going to be minus 1 whole to the power of I plus 1, and then sum of I, and then x minus I plus 1 for I ranges between 1 and x. So let us see the approach for this, and then see the constraints for this. The constraint states that n n ranges from 1 to 10 power 4, and then nums of I ranges from minus 10 power 9 to 10 power 9. And then it has been mentioned that n into k will always lie between 1 and 10 power 6. That means there is a clue that if we solve this via this complexity, then we can figure out the solution. That means if we run with this time complexity, the solution will be accepted. So let us think in terms of this time complexity. Suppose, let's say, I want I want the subarrays with this particular nums with k. Yeah, let's think once again. This is the array, and then k equal to 3. Now I want 3 subarrays which can be picked from this array which has maximum value. And then what is the another scenario? Let's say k becomes 2. I want 2 subarrays which can be picked from this array, and then I want it to be maximum. And then what is the another scenario? I want one subarray out of this array which which has a maximum strength, and then the other can be, I do not want any subarrays from this nums. So the k can range from 3 to 0. That means this particular array can take 0 to 3, 0 to 3. And then one more thing, let us consider that we take only 3, and then now I want, let's say, I take one element for one subarray, and then I want k minus 2 subarrays from this particular index, to till this particular index. Then I cannot take for only this index. I should take for each index which is present in the nums. So it will be like each index with k. That means let us consider this. So I will be having dp of index and then it is going to have k. So this will be the array which will store the maximum value it can have at this particular index with these many subarrays which can be picked from the arrays which starts with index. Suppose let's say dp of 1 and then k equal to 2. That means I need to pick two subarrays from this index 1, index 1 to till last element. So that is going to be the answer. So that will be stored in dp of index of k. And then let's say we need to make sure the other condition. Let's suppose say we have 1 and then whenever we want to move to the next element we need to consider whether this this subarray is continued to the next element or not. Suppose let's say I take 1 and then I quit and then I'll start one more subarray for starting with 2. So then k becomes 2, and then index becomes 1. So that is going to be this solution. Suppose let's say I want to take 1 and then I want to continue this 2 as well for the same subarray. Then I don't increment k but I'll be continuing. For that we need to make sure that we need to say the index is already started and then we need to say that the subarray is already started. You can continue or you can stop from the next element. So that will be stored as, so we'll also have that state as well. This will store started or not. So this dp will store dp of k and then started or not. This will be the state of the uh, dp. And then let's see, yeah, let's see the solution. Let's see the solution so that we can understand better. Think of it as only recursion and then we'll see the solution. So I'll be taking the dp of 3 where it will consist of nums of I with to store the dp of all the elements, and then it will have k so that it will count all the subarrays which we need from this particular index to last, and then we will have 2. Why? Because one will be stating that the subarray is already started and then subarray is not started. So those are the two values which we are going to be storing, and then we'll call this recursive function, and then this recursive function will give us the answer. So let us think in terms of dp. Suppose let's say we have any recursion function. Suppose let's say I have any recursive function. This is going to be return type, and then I have recursion with some parameter. For this to write a recursion, whenever we are writing a recursion, we need to write invalid condition or small small input, and then at last we are going to return possible answer. Possible answer. We are going to return this. And then one more thing is we need to write the answer in terms of some operation plus recursion with some parameters change. This parameter will change based upon decrement or increment. And then we are going to return this particular answer. So this will be the template for any recursive function. Suppose let's say it is invalid condition, then we need to return the possible answer. If it is small input, then we need to return the possible answer. Suppose let's say this is in the middle of the recursion, then we need to figure out a way that it will do some operation, and then we'll try to decrement the parameter so that it will solve the solution for parameters which will be having sub problems. So that this will be the template for this. So we'll be doing the same thing. Suppose let's say k becomes 0. That means it is a least valid solution, least valid k. So whenever the subarrays which we want is 0, that means we do not have, we will not be taking any subarrays. So we'll be having a strength of 0. So we'll be returning that. And then let's say the array has been completed, the array traversal has been completed. Then we need to check two condition. One is that, let's say that I have a subarray which is picked at the last, like num size -1 at the last, and then this subarray has started, but we did not increase the we did not decrement this subarray, and then we passed it as index started, but I will be increased. Now we'll return 0. Why? Because this subarray has started but not stopped. So we'll stop at that particular time, and then we'll return this particular 0. And then let's say if it is non-zero, k is non-zero and then not 1, then we are going to say this is not possible. Then we are going to return the least possible answer, which is minus e 10 power 16. And then let's say the problem is already been solved. Suppose let's say I equal to 0 and then k equal to 2, and then index is started. If I visit now at the starting, then it will go to here, it will solve the solution. Suppose let's say when I come back again, then it needs to check the default value. If it is not equal to default value, then it is going to return this particular answer, because the problem has already been solved. Suppose let's say we have a particular index I. Now if if we pick this particular number, if we pick this particular number into this subarray, what will be the strength of this particular number? That is going to be nums of I. We'll be multiplying the nums of I, and then we'll be seeing whether k double equal to, if it is even, then we are going to say this becomes -1, and then if it is odd, it is going to be 1, and then we'll be multiplying with k. So you can see this here. So this will be the condition. So we'll be taking the nums I, sum I. Suppose let's say sum I means it is a addition of all the elements. So addition of all the elements means, suppose let's say a plus b plus c is sum of I, then we can write as a into some k, and then b into some k, and then c into some k. So instead of taking sum I, we are taking one particular number, and then again we are multiplying with k number, which will have the count of subarrays. And then to consider whether it is -1 or 1, we are going to say -1 power I plus 1. Suppose let's say if it is I equal to 1, then I plus 1 will be square, and then square of -1 is going to be 1. So whenever I, yeah, let's consider I equal to 1. I equal to 1 in the sense, this be, let us consider I equal to 2. Then this becomes uh, 2 plus 1 will be 3, and then -1 to the power 3 will be -1. So whenever k becomes even, then it is going to be -1. K becomes odd, then it is going to be 1. So we'll be doing the same thing. And then let's say this is the present number strength. So we can consider this particular number into our strength, or we cannot consider based upon our requirements. Suppose let's say we'll take the default answer as minus I minus I 15. We will have these conditions. Suppose let's say it has already been started. That means previous index has already started this subarray, and we did not end it. So we can consider the index with start index as false. Suppose let's say this is the index which we already started, and then now we can consider that we can stop here. We can stop here and then we can start the new iteration, or we can consider other possibilities. So we'll consider one particular case where the index is started. Then we are going to say this particular subarray will end here, and then we are going to move to the same index but with index started as false, and then we'll say whether if it is not started. Suppose let's say the subarray is not started, then we have two possibilities, that we can consider this particular number or we do not consider this particular number. Suppose let's say we don't consider, then we'll move to the next index, and then the subarray will not be incremented or decremented, and then index is not started. Why? Because it is already false, and then we are also not starting the subarray, and then we'll be moving to the nums. And then one more thing is, suppose let's say we want to consider this particular number in this subarray, then we need to add this particular number strength, and then we need to move to the next index stating that the index has started. That means the subarray has started as true. At last we are going to say dp of I of k, and then index started as, out of all the three possible cases we are going to take the maximum. So here if we consider, if the index is started, then it is going to execute this, and then it is going to execute this. And then if index is not started, then it is going to execute this, and then it is going to execute this. So for one of the case it is going to execute 2, and then for one of the case it is going to execute 2. Because it is common for both of these, so we are writing out of if else, so that it will execute the same for both the cases, and then at last we are going to return as true. Yeah, and then one more thing is, we are defining this dp and then this n, and then we are, yeah, this will be, I am defining long as ll. So if we come to the time and space complexity, the time complexity is going to be big of n into k, and then we are considering two cases. And then coming to the space complexity, it is going to be same, big of n into k into 2. So this will be the time and space complexity. Suppose let's revise this. So we are defining the dp, and then we are calling the recursive function, and then this condition will have the like invalid condition or the smallest input, and then we are returning the answer. And then one more thing is, if problem is already solved, then you don't need to solve the solution again. So that is a case we are writing. And then these are the some of the cases which we are taking. Some of the cases, like we can pick the number, we do not need to pick the number. So these are some operations, and then out of these operations we are taking the maximum, and then we are assigning it to the answer. Yeah, that's all for this video. Thanks for watching. If you do like the video, do like it, and then subscribe to the channel. Thanks. Bye.